Before we go deeper into the series, let's quickly answer the basic question. What exactly is an LLM and how does tokenization connect to it? AI is the broad umbrella. Inside it sits machine learning, inside that sits deep learning, and inside deep learning, we have large language models, LLMs. So, an LLM is basically a deep learning model trained specifically to understand and generate human language. At its core, an LLM does one simple thing: it predicts the next word. Give it, the sky is, and it predicts blue. It's trained on huge amounts of text, so it gets really good at this prediction over and over, word by word. But here's the catch: an LLM is just a neural network. And neural networks don't understand raw text at all. If you feed it "Hello World" directly, it means literally nothing to the model. This is exactly where tokenization comes in. It's the bridge between human language and what the model can actually process. Text gets broken into tokens, and those tokens get converted into numbers, and only then can the LLM start working with it. So remember, without tokenization, there's no understanding. It's literally the first step in everything an LLM does. And that's exactly why we started this series with it. Today, we're talking about a fundamental but super important concept: tokenization, and the algorithm behind it called BPE, or Byte Pair Encoding. Let's start with why tokenization even matters. AI models like GPT or Claude don't understand raw text, they need numbers. So every piece of text you type first gets broken down into tokens, and each token is mapped to a numeric ID the model can actually work with. Now let's look at how BPE works. It starts at the smallest possible level, individual characters. Take the word lower, it gets split into 5 separate characters: L, O, W, E, R. Next, the algorithm scans the entire dataset to find the pair of characters that appears together most frequently. In our example, the pair L and O shows up the most. That most frequent pair gets merged into a brand new single token, low. The algorithm has now learned that L followed by O should be treated as one unit. This process repeats over and over. Find the next most frequent pair, merge it. Low and W combine into low, then eventually low and merge too. And this continues until the vocabulary reaches a target size, usually somewhere between 30,000 and 100,000 tokens. And the final result? The word lower is now represented by just 2 tokens, low and That's exactly why it's called byte pair encoding. It reuses common subwords to keep the vocabulary compact and efficient. In the next video, we'll dive into embeddings. See you then.